going to have a look at the type of SQL that we might need for our kind of basic pen testing. So it's a bit of a SQL 101 primer type idea, but it's also got some weird stuff that you probably wouldn't get on day one or chapter one of a SQL book. Okay, so we'll just cover some basic stuff. So I'll cover the real basics. So some people maybe not done SQL. I would definitely like get a basic SQL book, maybe the O'Reilly basic SQL book, or something online, some sort of 101, and just cover the absolute basics. But hopefully this half an hour with maybe a book with some examples, you might just get, you know, enough that'll make sense, because you don't want to do this stuff just not understanding how the queries work. It's really just a little bit pointless. Okay. But I'll try and get you some of the fundamentals that. So I used to teach database at quite a low, like second year undergrad. I used to work in database, and I was a bit flummoxed at how they were teaching it and the understanding of the students. So I'll try and give you things that I tried to get, you know, some of the fundamentals that maybe isn't obvious and isn't always taught and isn't always in the books and things. So relational database is what we're looking at rather than any other type of database. So relational databases are made up of tables. Okay, so tables are made up of rows and columns. Now, if you get the fundamentals of what tables are and what rows and columns are, and how the SQL works with these three basic things, if you get that, you'll just about have enough to get by. Okay, so you might even get by if you just get enough out of this stuff. Probably need some examples and just do some examples. So tables are your kind of objects in the database. So your objects or your kind of units of your entities are your tables. Okay, so if we're talking about Rotten Tomatoes or something, we'll have films. Okay, so this is a simplified, just made it up, just a three. It's got three examples filled out. So your table definitions are basically the types. Okay, so before you fill them up with data and you fill up rows, you basically have to define the type. So the type of the object or the entity is defined by the columns. Okay, so the columns are what the type is. So they're the attributes of the type. So in this case, we've got film title, year, description, director, and genre. Okay, and the ID is fine, but that's just really for indexing. But really, it's the data that makes it up. Okay, so the data is different types. So it may be numerics, it may be dates, it may be text. Okay, so this one's likely to be text. It has different lengths. So description obviously needs to be a bigger length than maybe codes or names. Okay, so that's fundamentally how the stuff's made up. Your records within that, once you start filling the table up, these are your instantiations. So your rows are the actual records. So these are your actual films. So that's kind of once you start putting data into the table. So the actual table and the columns are the definition of the object. Okay, so that's what you do. You create the definitions. You obviously have to design the entire database with lots of different tables and how they interact, because you want to separate data out into different tables. We're just literally going to be working with one table at a time. So don't worry about, you know, proper relational databases and tables. But obviously, you know, in a real application, it'd be selecting from lots of different tables to keep the data in different places for lots of different reasons. So your rows, once you start using rows, that's your actual data. So you fill up the rows. So that could have hundreds of rows. Okay. And your rows are usually what you're interested in, the actual data. So that's where your selects and stuff come in, and we'll come to that. So your selects can define which columns you get and which rows you get. Okay, so if you think of the table in the 2 dimensions, and then once we get to the SQL, think about how it selects each dimension. Okay, so how it selects what attributes it wants and how it selects how many rows or how little rows it wants. Okay, and that's the fundamentals. And no one seems to get this. I don't know. It's not taught well. I'm probably not teaching it well, but that is the fundamentals. And if you can get that, then most of the other stuff sits on top of it nicely. It's all just really the techniques and the terminology. So yeah, see what you think about that. So we define our table and then we'll add rows to it. Okay, so we've got columns, and these are different types, and they will contain different things, and you define that when you define the table. And then when we fill them up, the database won't allow you to put, you know, big bits of text into a date field or a time field. And if you've got a numeric field, you have to have numeric. So it keeps integrity of the database and what you're putting in these things. And it means you can do different things, calculations on certain things. You know, you can do date things on dates, and you can take two dates and compare them. And you can do things with strings like search for things. So if we're searching for film titles or film content or something, we can do things like that with wildcards. So there's reasons for all this. So columns are your attributes, and these are different types, and they're set up at the beginning. And then each row has to be unique in relational databases. We usually do that with an ID column, with a hash column or something, but in original relational databases, you would generally unique on multi-column values. So not too important, but just for accuracy. So yeah, so we have different sizes and stuff as well. Now, why might different sizes be interesting to us from what we've done already? So we're going to try and misuse a data field. We're going to try and get some information out through that normal use screen that we had. We're outputting some information from some columns. So why might different sizes of columns and types of columns be interesting to us? Any ideas yet? That's okay. Just keep that thought in your mind, though. We've got big text fields, and we've got small things, and we've got dates and numbers and things, right? So similarly to maybe when we did our memory overwriting, you know, we had numerics and arrays, and we had strings, lengths of things. We're overwriting things. We're pulling things back. We maybe had to show things in the debugger in different ways to make sense of numerics or strings and different things like that. So similarly with this stuff, we might be interested in the types. Okay, so SQL is the query language. Okay, so we've got our tables, columns, rows. You know everything about the database structure now. You're database experts. All we need to do is learn a bit of query language, and we can do things to the database. We can create those tables. So we can create the attributes and the tables. We can insert rows into them. We can update them, and we can query out of them once we've got data in there. Okay, so once we've got our films database filled out with some rows, we can then query. Okay, so some of those things we might try and do by injection, by putting things into these data fields. Some of the things we maybe wouldn't do. I can never think of a reason that you want to drop a table as part of a pen test, but people tell me they do it as part of like different things that they're doing, part of a technique. But I would think probably getting data out is the most common thing. Maybe updating some things, maybe changing permissions, you know, depending on the types of attacks you're doing, what stage. Tempted to asking a certain person a question. So yeah, these are the different things we can do with the query language. So you don't need to know all this. We're not going to start by building the tables. You know, if we're doing a 3-week course on this, we start by building tables. I'd teach you how to do SQL. I'd teach you all the fundamentals till you were bored to death of it, but you knew it inside out. And then we'd move on to the stuff. So we're going straight into, you know, doing attacks today. So we're really focusing on select statements. So if you can get the basics of select statements and how they work, and again, that's based on columns and rows. Okay, so columns and rows. Keep thinking that. Table, columns, rows. Take some notes if you're not sure. Write these things out when you do the labs. Go back to the slides. Try and go through the slides and use them. Okay, so we're going to put some rows in. So yeah, so things like inserting and updating, things like that. We could do stuff like, so you know how we did stored XSS, yeah? So we did stored cross-site scripting. We put things onto the storage somewhere, and then when that read the storage, it actually ran the attack. Yep, so we can do same thing here. Do second or third phase SQL injection. We could inject SQL somewhere and then run it, you know, when we lift it off the database kind of thing. So you can use updates and inserts to do things. That sort of makes sense. Drop tables, don't know. You know, deleting rows, not sure. So I haven't even got drop table on here. So that's another SQL command that would be a common one to learn at the beginning. Right, so this is our SQL for selecting. So this is our query language, SQL, you know, structured query language for actually getting some stuff off the database. So again, we've already seen this. We saw this in the web app for our use case, for our normal use case. Select some rows, select some columns from a database, and there was a where clause which was based on our user ID. So the where clause dictates which rows we get back. The columns dictate which columns we get back. So the beginning of the select dictates widthwise what we get back from the table. Okay, so the table is this wide. It's got 6 columns there, or whatever it is. 1, 2, 3, 4, 5, 6. The select left-hand side before the from, the first bit of the select is basically just the width. It's the number of columns we're getting and which columns. Okay, so if you can remember that or jot it down, that is incredibly important. And the amount of students that I see try to do the SQL and they're misshaping the SQL, they don't understand. Select columns. Okay, if we've got one table, it's quite straightforward. We're just going to specify columns. So select star is all columns. Okay, so we'll just start with that. We'll get the whole table. Select star from film or films or whatever it's called, the whole table. We're not restricting the number of rows, so we get all the rows as well. If you don't restrict with a where clause, you get all the rows. Okay, so that's important as well, because we might want all the rows for things. We might just give me all the data for something. Okay, so, but select star all rows. If we want to specify particular columns, we just put the column names in. Okay, and we can actually use, sometimes we can use numbers as well, like I want the third column, select 3. So that's useful sometimes as well. But in this case, film ID, title, year, description, director, genre, from film. So that's exactly the same. I want all 6. Okay, and it gives you the same result as star. All right, but the point is, it's that direction. So it's basically giving you that number of attributes or columns, and then we're going to get rows as well. Okay, so select title from film. How many columns do we get back? What do we get back in our data set? How many? Select title from film. I want some fingers in the air. How many columns?
Just one.
1. Good. So I'm not sure everyone's completely getting it. So select which columns we want back. Okay, this one we're just saying title from film. So we get 1 column. Okay, so this is the entire thing just for reference. That's the data set we would get back. Okay, so if we said select title description, we'd get those 2 columns back. And because we're not specifying anything else, we'd get all of them. So you get 3. Okay, Big Sleep, Big Lebowski, Big Blue. Okay, so you've got to get this. If you don't get it, sit down after and just have a think it through. So obviously we have to whiz through. So select title, year, director. How many columns do we get back in our data set? Let's see, fingers in the air, please. Every single person. Hold up how many fingers. How many columns do we get back? 3. Yep, 3 columns. Yep, because we're asking for 3 things in the left-hand side of the select. Okay, so fundamentals. Any questions? Go through it again. Right. So you've got select from table, select columns from table, and then we'll have a where clause, which we'll talk about a little bit. So basically, if we're dealing with one table, it just specifies which column. So how wide our data set is we get back. So it can be any of the columns in any order. We can select the columns twice. We can do whatever we want. There's loads of things you can do with database. It's a really interesting topic. So basically, you can go through these examples and think about it. So that's the same example again. Select star. So we use wildcards just to say all columns to save us typing them all in and that kind of thing. And if we're using multiple tables, we can then start joining tables together and selecting lots of different, can create data sets from multiple tables, which is so much fun. We used to do things that were on, I don't know, we used to do selects that were about 30 pages long, you know, like amazing things. So this is super simple. If you get the basics of it, you know. So now we're going to go the other way. Well, no, we're not. We're going to stick on the left-hand side. So, right. So this is where the 101 primer starts to go a bit wonky, because you would never learn about this generally in the first day of a SQL course, say. But we're going to learn about it because it's fundamental to what we need for our pen testing, our attack stuff. So, query comments. Okay, so we've got our select columns from table. We're going to do some other stuff soon, but we're going to learn about comments. Okay, so inline comments in MySQL, that's what we're going to use. So they're done slightly differently, but they're all pretty much the same. So a comment on a SQL statement, an inline comment, so that basically comments out the rest of the line. So you can put some documentation in, or you can stop by using something. Is minus space. Okay, so minus space. I'm going to say it a third time. Minus space. Write it down. Don't want to hear it in the lab. This minus minus doesn't work. Minus minus space. Okay, you need the space. So if you're injecting into a URL and it's URL encoded, does anyone know what it is? Minus minus. %20. So it's a space. In some browsers, it'll give you %20. If you want to inject the encoded, it's %20. So just remember that fundamental, because people waste a lot of time on that. I don't mean to sound rude, but students, maybe distance learning students, they'll sit and waste a lot of time, and not be able to get any help. So minus minus space. You can also use hash as well, which is good. So yeah, if you were doing multi-line statements, so if you're doing select column and then the next line column, from table, where, blah, blah, blah. So you would generally have these things all split up so you can move them around and do things. You might have inline comments on the right-hand side. So when it takes the statement, it'll take the whole statement. It'll just ignore anything after the comment. Okay, so anything after the comment, it'll ignore. But if you have a one-liner, so you've got select, columns, from table, where, blah, 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 we're not interested in all the detail. If you put a comment in, it will basically ignore everything after the minus minus space. Okay, so any idea why that might be useful to us? What could we do with a comment that ignores everything to the right-hand side? What could we do?
Stop the rest of the query.
Yeah, ignore some of the query, stop some of the options. So if we're injecting into a box and it becomes part of a query on the back end, so our one, remember, got injected into the where clause. So it was where user equals 1 and blah, blah, blah. We could put a comment in which says, you know what, see when you build this select, stick this comment in the middle, and then everything in after that, we're just going to ignore. Okay, so if you can visualize it and you can experiment with it, you can use this to block out query, code, SQL that's in the application itself. So it could be the application has 500 lines of SQL in the where clause. You put that in at the beginning, it's going to ignore everything and just use your injected bit of SQL maybe. So you can bypass things. You can completely ruin their queries, just get rid of everything and do your own queries. So lots of different things you can do. So that basically gets rid of everything that way. There's techniques for getting rid of everything the other way too, which we'll come to. Okay. So it basically ignores everything. So if we're building into queries, then we can get rid of a lot of stuff really easily. So another thing that you wouldn't probably typically get in chapter 1 of our SQL manual is concatenation. Okay, so but again, could be useful to us. We'll use this in the labs. When you come to the question, it says maybe concatenation is useful. I don't know how many people put up their hands or ask questions. How do we do this? So when it says concatenation might be useful, come back to the slide, look it up. Okay. So concatenation, again, we used this in our code injection stuff, our memory stuff a few weeks ago. We used things like substrings and concatenation. If you missed that question out, bad luck, we're coming back to use it again. Okay, so same stuff, slightly different terminology because it's in a SQL statement, but it's for the same reasons. We're basically able to bring things together and output them, or maybe substring, like pull different bits out. Okay, so I think substring we do as well. So concatenation kind of links into my question about if we had big text fields or big text data on the database. Okay, so anybody got any idea? So there's an example there. We can cat a few things together and we output in one field. Output in one field. So any ideas how we might use that when we're doing some sort of attack or injecting stuff into SQL? Boom, that's it. So maybe if we've got limited space on our output field on our browser, if we're using something that just outputs like a film title, but we want to get 15 columns out of the database, we can maybe build some stuff and then concat it all together into one place. We can even use it like here just for formatting, to nicely format and say, yeah, we found the user's name and their password and this and that from these tables. We can spit out some nice data even. But yeah, generally it's used because we maybe don't have a lot of space. We maybe only have one thing. So that's why big text fields are useful. If we can find something, we've got a lot of space, a bit like buffers, if we can find something that's got a big bit of space, we can use that to get something useful in there. In this case, it's the other way around. We're trying to get stuff out. So if we can find a big buffer, we can maybe load it full of useful stuff once we get access to the database. Okay, so same sort of thing, substring, you know, I'm not going to go over it in great detail. That's how it works. It works slightly differently in different databases. So you can select a column and you can select parts out of it. And again, you can start hopefully thinking about the methods we've used before and think, you know, how we maybe misuse some stuff, and you know, this is going to be pretty similar. So just come back and look it up. These might be a good trigger if you just go back through the slides when you're doing the labs. So these are useful things. Global variables, database procedures or functions that are built in. Okay, so usually databases have got a lot of stuff built in. Usually they are global variables or something on a table somewhere which is mimicking a global variable, or a database procedure which you can run. So things like, you know, get database or get user or version. There's usually lots of them. So why might these be useful? Any ideas?
It's Richard, to be for vulnerabilities and
Yeah.
to know what exact database to select.
Yep, well, that's it. So one, we could get a database type, maybe vulnerabilities and things like that based on the version. There might be things we know. Databases might run as certain users. So if we could get something that runs as root or as a more powerful user, then we get more permissions and we can do things. Ironically, when we started putting proper defenses into databases, what we did was we tended to hive off everything into the data store itself. So we had stored procedures which did everything, and we parameterized them so you couldn't pass the data in and attack things. But the stored procedures, to call them, you needed the application to be running at a privileged level. So you ended up with like quite a lot of privileged processes running, which then if you compromise, you get full access to everything. So that's kind of been fixed in lots of ways now. I haven't looked at all the latest stuff, but it's interesting to sort of see you try and defend and you cause more problems by putting in defenses like that. So it's a good way of doing things, and I cover a little bit on it at the end. We don't really have time to go into a lot of the mitigation. So the where clause, right? So this is the next bit. So we've done the other part, just the select, the columns, so the width, and we're going to play around with the output. So that's all in the select. So when you come to substrings and formatting the outputs, things like that, that's all in what you're selecting. Okay, so the width and then the format and the types and casting. We could cast one type to another. We could cast a number to a string if we had a string output, etc., etc. This is the other way, how many rows we get. Okay, so a where clause is basically a filtering clause, so it reduces the rows. If you don't have a where clause, you get everything. Okay, so if you select from 15 tables and join them all together, you get every single thing that's possible. So if you get one table, you're just going to get all the rows. So for our example, Mickey Mouse film database, we've got 3 rows. So if we don't specify a where clause, we get 3 rows. So if we don't put anything in, 3. If we put in a where clause, we generally will get 3 or less. Okay, so we'll generally like reduce the rows. And it's for filtering because we want a more specific answer. So if we're looking for films, we'll probably search on film title. You know, Rotten Tomatoes, we're going to go, you know, Rich likes a rom-coms, we're going to put rom-com in, and it'll maybe look for rom-coms in the title or the type. Okay, or maybe we're looking for a specific film, Godfather, and you're going to get 3 or 4 Godfather films because that's going to search some sort of description or title for the things you're looking for. So that's a way, you know, where the where clause is going to reduce the number of things you're looking for, which is typically how we use it to specify particular data that we want back from the database. Okay, so there's lots of different things. You can have incredibly complicated where clauses. Like I say, we used to have where clauses that were, you know, 20, 30 pages, sometimes unions and where clauses, huge select statements from massive amounts of tables. But we're using one table, so it's fairly straightforward. You just need to know the basics of how the where clause works. Okay, and how it works is it's a set of conditions. So it's basically a set of Boolean conditions. If the conditions all equal true, you get the row back. If the conditions all add up to false, no matter how complicated it is or how many there are, you don't get the row back. So it's as simple as that. Columns, cross away, rows this way based on Boolean true and false. Okay, if you get that, you will understand how to do all basic SQL. Okay, no matter what the syntax is and no matter how complicated the stuff is you layer on top. Okay, so where clause, number of rows, and it's basically just based on these conditions. So if I say where film name is like Godfather. So anything before and after, and it's got Godfather in it. Okay, that one where clause is going to reduce all the rows just to the rows where that's true. Okay, so it's going to try Godfather in every single row. It's going to look for it, and it's just going to return those rows, that data set with Godfather in the title, perhaps. Okay, so we'll go through a couple of quick examples, but it's really as simple as that. So don't worry about it getting super complicated. If you can remember just creating things which will either be true or false for a row. So it goes through every row in that data set in the database, and it just checks whether that statement is true or false. And if it's true, gives you the row back. Then it specifies the columns from the first part, so it just gives you those columns back. And in that way, you create a data set, different sizes and different shapes. Okay? And then you add multiple tables in, but we're not going there this week, so don't worry about that. Okay? So that is it. So these are some simple examples from this table. So select star from film where title equals big blue. How many columns do we get? Select star. 6. All columns, 6. Yeah, so 6, 6, 7, 6. And how many rows? 1. Because it says equal. Yeah, it says equal and it's got a specific title. Okay, so true or false. So what it does is it inserts the titles for every row and checks. So it says the Big Lebowski equals the Big Blue. Is that true or false? False. So it doesn't return the row. It says, try to remember the other one I had. What was the other one I had? The Big Sleep equals the Big Blue. True or false? False. So it doesn't return the row. The Big Blue equals the Big Blue. True, so it returns the row. It's as simple as that. It doesn't matter how complicated the where gets. It's just a true. It's just a true or false you're looking for. Okay. So if you can remember that, and the columns go this way, and then there's a bit of format, and Bob's your uncle. You'll have the whole thing. You'll be absolutely sorted. Okay. So just keep coming back to that. That's the basics. And what I find is a lot of students have done 2 years of database classes, and they do not understand this fundamental. They do not get. They're like, yeah, where clause does this and blah, 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 and it does that. And you get these data sets and it's like, and you do unions and blah. This is the fundamentals. You get that. I think everything else sits nicely on top of it. So try and remember that. Okay. So yeah, so you've got, different things. Generally, you would probably be doing things like conditionals, saying I want all the films that are like this, or all some data after a certain date, or, you can start imagining your websites now you're using. Hopefully you'll start imagining using your phone and you're thinking, right, I'm typing this in. What does that actually do? What kind of query might it build? Because if you can think about the query, then you can think about, if I insert that into that sort of query, would that do, I could use that technique for this sort of query. Okay, so this is how you start building up your, your skills and thinking about how we might abuse this stuff. Okay, so wildcards, again, it's just a technical thing as part of a where clause. So you just need to know how a wildcard works for that database. Generally, it's a like operator. So it will say where film name like Godfather with some stars or some percents. Usually we use in database just to be awkward. Okay, so there is reasoning for that. But usually one character matches is something like dots or underscores, depending on what you're using. More than 0 or 1 match is a percent typically in the database. So again, it's just a matter of coming back to this and saying, how does a wildcard work? Okay, but obviously that could be useful if we could inject selects that do wildcard matching on things. We could maybe look for column names or for values that we're interested in. So we could look for column names that are maybe like something. So we don't need to know the exact column names that we want to fish out the database. We just maybe need to know that it includes PASS, for example, and that possibly will give us back columns that are password columns, no matter if they're PASWD, PASS, PS, different things. So we could use that to maybe find things. So it's quite a good way of finding things. If we can get some SQL to inject, and we'll look at that later, doing a wee bit of finding. So a lot of these things overlap as well. If you can use one technique to do one thing, then you can maybe use that technique to do something similar somewhere else in the methodology. So again, it's all kind of layering the stuff together. So yeah, that's an example. A really bad example because it's getting where the title of the film is like percent big percent. So anything big anything in the title. And obviously that's a bit rubbish because it just gives us everything. But if we had lots of other films, then obviously it would give us all our favourite films, or some of my favourite films with Big in them. If you haven't seen these films, watch them all. Excellent. Big Sleep, 1946, classic. Okay, so yeah, maybe some more useful. We were actually restricting. So we're restricting the rows again. What the where clause does, gives us usually less rows. So it's a way of filtering. So again, just checking for true or false for each row. Select all the columns. Where director like starts with Howard, anything after that. Okay, we're just going to get the one back because when you insert the directors in, it's the only one that matches Howard Talks. Okay. So as simple as that. If you get that fundamental, you know, you'll learn something good, especially if you've not done much SQL. And think about just building all the techniques and tools and stuff on top. So another one you probably wouldn't generally get straight away with SQL is order by. So we're going to use unions, we're going to use order bys, and we're going to use nulls, cut columns, which are a bit tricky, but I'll just let you know how they work, and then you can come back to it and then just, if you work on it by example. So basically order by is just sort. So it's a way of sorting output. And again, it just goes in like the where clause. So it goes in after the where clause. So you can put a where clause in and then an order by, and you can use multiple things. It becomes quite complicated, but simplistically, it's just used for ordering. Now, we can use this technique for certain things, which is not what it's meant for. So again, we're just going to misuse it for something, which we'll see later, which is quite useful for enumerating the database. So if I do select star from film, we get all the columns, we get all the columns, we get all the rows because there's no where clause, and I want to order by year. Okay, so I want to order some of my favorite films by year, so I can look at the oldest ones and the newest ones there. Okay, so orders them by year, orders them 46, 88, 98 there. Got the year right. And what's interesting is we can, a bit like select sometimes, order by is generally always we can do by position. So we can order by the numeric position of the column rather than the column name. So what does that help us with? If we don't need to order by the column name, we can use a number instead. What do we not need to know? We can use a number. Column names. Now, if we're using a front-end client, yeah, a web browser, we don't know anything about the database yet. We don't know anything about columns or tables or anything. But we could insert selects to look at column numbers. So what might that tell us? Possibly we could enumerate column numbers and things by using that with numbers rather than names, because we'd have no chance with the names. We could you know, guess them. We could just guess, and we'll do a little bit of that in the lab. You see how boring it is. But we can get tools to guess things as well. But we can also use that technique. So that's quite a good technique. So why have I given you these slides? What might these slides be useful for, this little half-an-hour section? Labs. Right, come back and use the slides. So just think about maybe, you know, pulling up the slides and having them in a window beside your labs and stuff. So I only see limited people doing that, and I think it is super useful.